So good morning. This is Unit 1, Day 7 notes. We're going to go over transformations. So you're just going to remember what a parent function is. Let's say our parent function is a square root of x, and we're going to see what happens when we transform it. So if we have a minus 3 on the outside of that square root of x, then that's changing our y values, and we're actually going to go down 3. Minus 3 means down 3. Since this negative 2 is on the inside of the square root, it's the square root of x minus 2, we're actually going to do the opposite of this sign. So since it's negative 2, you would think we go to the left 2, but actually we're going to do the opposite, and we're going to go to the right 2. 2 times x underneath that square root is going to be a horizontal dilation by 1/2. And this is our k, and it's actually, this 2 is going to be our k, and that's actually going to be always the absolute value of 1 over k. So just so happens to be 1 over 2. When we reflect it across the x-axis, we're going to have a negative out in front of that square root. So that's reflecting it across the x-axis. So negative square root of x. When our negative is inside our square root, then we're going to reflect it across the y-axis. So this across the y-axis. Consider your following function. We're just going to look at how these values transform our original function. When our p is less than 0, this is going to be a reflection, and our p-value is going to be the vertical over the x-axis. And so if there's like a negative on the outside, that flips it across the x-axis. Our k is going to be the horizontal, and that's over the y-axis. When the absolute value of p is equal to 1, this is a dilation. Not equal to 1. I'm sorry, when the absolute value of p and k are not equal to 1. Otherwise, it'll just be our original function. But we have a dilation. Or a stretch. Okay. It's also called a compression. So we'll stretch it or compress it. If it's our p-value, that's vertical again. Our k is going to be horizontal, and we can find this by the absolute value of p, or as I said before, it's going to be the absolute value of 1 over k. So it's always going to be positive. Our a and b. Our a is going to go from left to right, so horizontal right or horizontal left. And this is based on whether a is positive or negative. Remember, we do the opposite. So right here, x minus a, maybe x minus 3, means we're going to go to the right 3. But if it was x plus a, then we would go to the left, the opposite. All right, these are called translations. Translation means to slide. Okay. Horizontal, we also have vertical translations. We can move them up and down. And this depends on the b value, the b. If my b is plus b, then we're going to go up. We're going to keep the sign. If it's negative b, then we would go down. This one we don't change the sign. All right, let's look at this. We're just going to graph them based on the transformations. So we just need to know the parent function, the absolute value of x. This is going to look like this. It's a v, something like that. 1, 1, 2, 2, 3, 3, 4, 4. All right, and we have to do this in the correct order. We have to do the reflections and dilations first, and then we can do the translations. Otherwise, it'll change our graph. So right here, it looks like we're flipping it across the x-axis. So I'm going to show you this first. Flip over the x-axis. Okay, and that's what I'm going to do here. So this is my new graph. And then we are going to have a stretch. This 2 is a vertical stretch by 2. So usually we would go up 2 over 1, up 2 over 1. But this time, we flipped it. So we're going to go down 2 over 1, down 2 over 1, something like this. Something like this. Alrighty. Now we can do our translations, and it says to go to the, so x minus 1 means we're going to go to the right one. Okay, this is where I got it from, right one. So I'm just going to move this one over here, and then still go down 2 over 1, something like this. And then the plus 4 means that I'm going to move it up 4 units. So it was right here. I'm going to go up 1, 2, 3, 4. So this one is, I guess, blue. And this is the plus 4, up 4. And that's this. So it's pretty simple, just kind of reviewing transformations and functions. All right, guys, I will show you this one, and then I want you guys to try one. So we have 2x plus 4 and then minus 3 on the outside. We have to remember that we have to factor out anything in front of that x if we can. So this is going to be the square root of 2 parentheses x plus 2 and your parentheses, and then outside of that square root is minus 3, right? So we know that the square root of x just kind of looks like this. This is my normal function. We factored out a k. And so let's look at our dilation first. My dilation is going to be a horizontal dilation by 1, so k is 2. Remember, we do the absolute value of 1 over k, 1 over 2. So this is a horizontal dilation. So just like the square root of x goes through 1, 1. When we substitute in 4, we get 2. 2, or the square root of 2x, when we substitute in a half, we'll get 1. And then when we substitute in the 4, but when we substitute in 4, it'll be big, right? And we'll take the square root of that. But when we substitute 2 times 2 is 4, the square root of 4 is 2. So when we substitute in 2, it grows a little bit more. Oops. I don't know what happened. It's just growing a little bit faster by 2. Okay. And then we can do whatever is in the inside of the square root. We're going to use our transformations, our translations. So we're going to go to the left 2 because it's x plus 2. So I'm going to show you guys right here. I'll just highlight it. So this means to the left 2. So I'm just going to move this whole thing to the left 2 units, and then keep going. And then this minus 3 means that I'm going to go down 3. So I'm going to start here, down 1, 2, 3. Let me just write it, sorry. Down 3. Go 1, 2, 3, and still translation. Alrighty, so that is going to be our transformation based off of this function. I want you guys to try these. I'm just trying to see if there's anything else. I really want to go over this one because this is something that we're going to see often. So we have 1 over x, which we kind of know that 1 over x, we have an asymptote at 0 when x is 0. And we have an x asymptote since the numerator is smaller than the denominator. We have an asymptote right here also at y equals 0. So my graph at 1 over x looks something like this. Okay. Now, when I do 1 over x minus 3, this means we're going to go to the right 3 because it's minus 3. We do the opposite. And then we have on the outside of the function minus 4. So we actually are going to go down 4. And this is going to make our asymptotes go to the right 3. So we have 1, 2, 3. And then it was at y equals 0. Now it's going to be down 4. 1, 2, 3, 4. And it's going to look pretty much the same. There's no negative or anything on the outside. So it's going to look in this, it's going to be in the same quadrant. You can test points to make sure. Alrighty, that's it. It says that we need to rewrite this. So we can separate the numerator to be over the same denominator, or we can divide it. So let's try to divide this. I think we need to divide this. We have x minus 1 goes into 3x plus 1, and x times 3 will give us 3x. So 3 times x is 3x. 3 times 1 is negative. So 3 times negative 1 is negative 3. We're always subtracting. 3 minus 3 is 0. That's why we did it. 1 minus negative 3. Sorry. I wrote it down wrong. So negative 1 minus negative 3. So we can add the opposite, and this is going to give us 2. Okay. So this is the same as we're going to add the remainder divided by what we were trying to divide, x minus 1. So this function is the same as 3 plus 2 divided by x minus 1. Okay, I'm going to rewrite that. So g of x is 3 plus 2 over x minus 1. And now we can look at these transformations. So we are going to move it to the right 1. And we will move it up 3 since my 3 is positive. And we're going to look at this 2 on top. This is a vertical stretch. So vertical stretch by 2. Alright guys, I was going to let you finish this, but I want to try this one just because of the vectors. I want you to see what this would look like. So when they're talking about a translation of a vector PQ, your P is going to be your X value, how it's going to translate to the left or to the right, and then your Q is going to be your Y value, and we need to know this, okay? Let's look at number 2. It says we want to make this function look like vertex form. And what we're going to do, I'm going to go over this, y equals, remember we're always factoring out the number in front of the x squared. We have to factor that out. So that'll be x squared minus 8 divided by 2, which is 4. And then on the outside of the parentheses, I still have a plus 5. I'm not changing that. And then, sorry, there's an x there, right? Whatever is in front of the x, which is negative 4, we bring it out to the side, and then we divide it by 2. And this number is very important. Negative 4 over 2 is negative 2. And then we're always going to square it, right? And that gives us 4, positive 4. So this is going to be plus 4. But am I really adding 4 to this side? In fact, I'm not. 2 times 4, I'm adding 8 to this side. They're both positive. So I'm adding 8, so then I have to subtract 8 from the same side of the equation, right? I have it on the same side of the equation. Alrighty, so now I can complete the square. This is going to be 2 parentheses x, and then whatever this number is inside the parentheses before I square it. This is a negative 2, so minus 2. And then this whole thing is squared. 5 minus 8 is negative 3, so minus 3. So f of x equals this. I'm completing the square. And it says the graph of g is obtained by, so this is our f of x, g is obtained by translating the vector 3, negative 5. Okay, so my new vertex is going to be, this is 3 to the right. This is going to be, I'm sorry, so this is a x equals 3. But when we're plugging it into here, we're going to change the sign. So negative 2 minus 3 is going to be at 5. So my new vertex is going to be 5. When we plug it in, it'll be negative 5. So my new vertex is going to be at 5. And then remember, we keep the sign of our y value. So it was at negative 3. It looks like we're going to go down 5. This is going to be negative 8. And I'm just going to make sure that I plug it in properly. So my g of x equals 2. And then this is x minus 5 squared, and then minus 8. Keep the sign of the y value. Okay? I want you guys to try see. It says that h, so we have f of x and g of x, now we have h, has been obtained by translating g. So we're going to start at g with the vector p over q. We don't know what that vector is, but the vertex is now located at 0, 3. So my old vertex, they're telling us to start at g of x, so my old vertex is at 5, negative 8. My new one is at 0, 3. How did we get there? What did we do to the x values? What do we do to the y values? Okay, I want you to tell me the new vertex, or the vertex of translation. Okay, this is going to be p and this one's q. All right, so try it out, and if you have any questions, let me know. Have a good day, guys.